Okay. All right. So here we go. Section 4.5. And the first thing that we talk about in this section is what we call combining functions arithmetically. Now, there are a lot of words in this section that are large words, okay? We can't let that scare us. The word arithmetically literally just means arithmetic. And when we talk about the word arithmetic, that is add, subtract, multiply, and divide. And so when you see this word, so I'm going to jot this down real quick. So we're going to have combining functions. And again, if you want to write this, you can. If you want to just look at it in Blackboard, you can. Here's the word arithmetically. Sometimes even I pronounce it incorrectly, which should not surprise you guys. All right, oops. Arithmetically, arithmetic, okay? Add, subtract, multiply, and divide. And so what's going to happen, the first thing that we're going to do is we're going to be given two different functions, and we're literally going to do arithmetic with them. We're going to add them up, we're going to subtract them, we're going to multiply them, and we're going to divide them. And so what this is going to look like, we're going to say, let f of x and g of x be two functions. Okay, so what this means is you're going to be given f of x equals something, it's going to be a function. You're going to be given g of x equals something, it's going to be a function. Then we're literally going to add them and subtract them and multiply them and divide them. And so even though this looks kind of confusing because there's a lot of x's flying around, we kind of already know how to do this. Okay, so I'm going to have to write the list on the next page because I've already run out of space. And so let me show you what that looks like. Let me explain it to you in words. Then we'll do a problem, and then I'll let you ask your questions if you have them. So once we decide that f and g are functions, here are the four things we're going to do. The first thing that we're going to do is we're going to find f plus g of x. And I know this looks funny, okay, but bear with me through the description. When you see this, f plus g of x, that is simply f of x plus g of x. And so here's our first arithmetic function. The first thing I'm doing is literally just adding two functions together. The second thing that I'm going to be able to do is f minus g of x. Well, what this means is f of x minus g of x. And so again, my second arithmetic thing is for me to subtract. All right. The third is for me to actually multiply. So this is just going to be f times g of x, which means I'm going to take f of x and I'm going to multiply it by g of x. And so the third type of arithmetic I'm going to do is multiplication. And then lastly, when I'm doing arithmetic with my functions, I'm going to divide. So I'm going to have f divided by g of x. And what that's going to look like is f of x over g of x. Now there's one stipulation here. Okay, we know that this g of x business, only when I'm dividing, cannot equal 0. I have to keep that in mind. Okay, so take a second, write these down, and then of course the fourth piece of arithmetic is me doing this division. So I'm adding, subtracting, multiplying, dividing, and that's it. What are our thoughts on the way that this looks?
I mean, it seems straightforward, but I'm not sure yet.
Well, of course, we haven't done a problem, but as far as what it looks like, let's see. Okay, so some people are saying not too bad. Okay, so why don't we go ahead and we need to talk about the domain, which will be the next page. I have to write a few things down, and then we're just going to dive right into a problem, and we're going to do this. We're going to add, subtract, multiply, and divide, and we're going to see what you think. Okay, and my guess is you're going to be like, oh, that's not that bad, which is the goal. Okay, so let's briefly talk about the domain. Of our new function, so to speak, because when we take a function and we add a second function to it, we're going to get a brand new function that we haven't seen yet. And so we're going to have to look at the domain of the f, the domain of the g, and the domain of the new function. So let's do that, okay? So the first thing, or the thing that I need to write about the domain is this. We're going to say that the domain, which we know are the x values, the domain of the, in little quotes here, I'm going to say new function, okay, because we're going to have a new function, is going to be the intersection of f and g domain, f and g's domain, individually, and I'll show you this as soon as we get it all written out, okay? Individually, However, this should be a y. However, we must take into consideration, so taking into consideration that g of x cannot equal 0 when dividing. Now, I know this doesn't make a lot of sense right now, so just write it down, okay? And then I will show you with an actual problem, and I promise it'll make more sense. So the domain of the new function that we're going to have is going to be the intersection of the domain of f and the domain of g individually. However, we have to take into consideration that when we are dividing, g of x, which is the bottom, cannot be 0, okay? And it's going to be easy for us to see that once we see an actual problem. All right, so let's go ahead and let's take a look at a real problem, okay? So do I need a second to let you guys write, or are we good?
I'm good.
We're good.
Okay, we're good, okay. All right, so then here we go. All right, so here's what's gonna look like. You're gonna be given a problem, and it's gonna say this. It's gonna say, so this is example one, f of x, and we're gonna start off easy with numbers, and then we'll build our way up to functions. So we're gonna say that f, wait a second, I have big surprise, I've already messed up. Instead of putting an x in there, I want it to have a -2. So f of -2 is equal to 1, and g of -2 is equal to -5. And so what this means is that somewhere above, somewhere up here is a function, and over here is a function, okay, whatever. I've taken the number -2, I've put it into this function, I've done some evaluating, I've popped out a 1. Over here on this function, I've taken the number -2, I've popped it into this guy, I've done some evaluating, and I've gotten a -5. And so what I'm going to do in this particular problem is I'm going to add, subtract, multiply, and divide. And so the first letter A, the first thing I want to find is f plus g of -2. And then I want to find f minus g of -2. And then I want to find f times g of -2. And then lastly, I want to find f divided by g of -2. Now, when we just have numbers, this is going to be the easiest thing probably we've ever done, okay? And so what's going to happen is, according to the notes that we just took on the previous page, if I have in letter A, for example, f plus g of -2, well, that's just f of -2 plus g of -2. Well, don't I already have those values up here? In this case, yes, I do. And so what's going to happen is my value, f of -2, is actually just the number 1. So 1, plus sign. My value of g of -2 is actually just the number -5. Well, this is just addition. What is 1 plus -5? Well, -4. -4 is my answer to letter A. So take a look at what we did. Tell me what you think. Anybody have any major issues with this right now?
It's different than what I thought it was going to be, but it's easier.
Okay, yeah, it's easy. So far, so good. So this isn't bad, okay? It looks a little different than maybe, anything that you've ever done in the past, which is fine. But we got to make sure, that it's not so bad, okay? All right, so let's take a look at letter B. So the same idea here, except in this particular problem, I'm subtracting. And so I'm going to say, all right, well, this is just f of -2 minus, hold on, g of -2. Well, again, I have my f of -2. I have my g of -2. So this is going to be 1 minus -5. Well, what happens when I minus a negative?
Turns on
Plus
to
a positive.
positive.
Yeah, and so 1 plus 5, 6. Done.
I'm confused because, like, for A, B, C, and D, it says like parentheses f plus g, and then it's like times. I'm thinking it's saying times -2.
Okay, so I can see what you're saying, and the fact that typically when we have parentheses, it does say that. Okay, but since we are talking about functions, remember when we talked about we did away with our y value and we brought in f of x. I'm going to write this down, but then I'm going to erase it. Remember how we had a y, and we said by y, and we brought in this thing that said f of x, and we write it as the parentheses meant the word of instead of just multiplication.
Yeah.
So when we look at these types of problems, this says specifically f plus g, it's not times -2, it's this of business.
Oh,
So
okay.
we say this is f plus g of -2. This is f minus g of -2. F times g of -2, and then f divided by g of -2. So we're saying the word
Okay.
of a lot, okay? And that's what this is saying. We're just taking these functions and we're adding them up, subtracting them, multiplying and dividing them, but by each other, not by the number that's in parentheses, by the whole function itself, okay? So if we look at letter C, this says f, this should be an f times g of -2. Well, that means f of -2 times g of -2. Well, what is my f of -2 value? Just 1, multiplication sign. My g of -2 value is -5. What's 1 times -5?
-5.
Done. Perfect. And then the last one, letter D, wants me to divide. And so what this means is f of -2 over g of -2. Well, again, I know my f of -2 value is 1. I know my g of -2 value is -5, excuse me. And so when I simplify this completely and totally, my answer is -1/5. And I'm completely and totally done with this problem. Okay, so I was given two function. In this case, I was just given values. We'll kick it up a notch in a moment and we'll actually look at functions, but we got to make sure that this value stuff makes sense. And then I added them, I subtracted them, I multiplied them, I divided them. Eventually, I'm going to try to get you to a point where you don't have to write this middle stuff every single time. My goal is for you to go from the problem to the answer in as few steps as possible. So take a sec, look over this stuff again. I'll erase some of this mess so you can actually see. And, you know, what do you think? What are your questions? What are your concerns?
You'll have to do each steps every single time for the problem, like all 4.
Typically, yes. But sometimes, and you'll see in a few minutes when we do a little bit of a different type of problem, we may not have to. But to start with, the answer to that is yes, because I need to make sure that you can. And once you get the fact that you can do it, the problems are going to change just a little bit. Okay, so for now, we're going to say, yeah, we're going to do this, all 4 of them every time. All right, anything else? Because I want to try another one. I want to do another one, rather, and let you guys do a little bit more talking. But I want to see what you think. We ready for number 2?
Yeah.
Okay, here we go. All right, so number 2, the same idea, but it's going to be presented to you just a little bit differently, okay? So let me write it down. Try to get some of this stuff out of the way here. All right, so here we go. Number 2, we are going to be given that f of x equals x plus 14, and we're also going to be given that g of x equals the absolute value of x, okay? So now this time, instead of me just being given function values, I'm actually given functions, okay? Now here's the thing. I'm going to be doing A and B and C and D just like I did, okay? So let me write a few things down. So the first one is that I'm going to ask me to find f of g of the number 1, -1, excuse me. And then I'm going to find f minus g of -1. And then f times g of -1. And then f divided by g of -1. Okay, now, just a moment ago, instead of having these actual functions, we just had teeny tiny numbers. So instead of saying f of x was x plus 14, I had a number. And it was a piece of cake because I was ready to roll. Well, here's how this problem differs than that first one. If you take a look, it doesn't tell me what f of -1 or what g of -1 equals. It just says, hey, I need you to go and I need you to find all this. And so the first thing that we're going to do when we're given just a function is we're going to take our value, which in this case is a -1, and we're going to put it here, and we're going to do some calculations, and then we're going to put it here and do some calculations. And then we're going to have f of x equals a number, and g of x equals a number, and I'm going to add those numbers, and subtract those numbers, and divide those numbers, and multiply those numbers. So let's back up for a second. Let's say, okay, well, I don't know what f of -1 is, but I can find that pretty easily. So right up here, I'm going to put f of -1. And anywhere I see an x in this function, which just happens to be one teeny tiny place, I'm going to put a -1 instead. And so I'm going to have, go ahead.
1 from.
It's going to be given to you in the problem. See this blue box right here?
Yeah.
That's going to be given to you. And typically, wouldn't this typically be an x right there?
Yeah.
Yeah.
Okay.
And since instead, blah, blah, blah. And since it's not an x, it's a number, that means, hey, I need you to find the value of -1 for this particular function.
Okay.
And so what I'm going to do is I'm going to take this -1, I'm going to pop it into this f of x, and I'm going to calculate it, and I'm going to get, 13? Now I'm going to put this in a box. This is not my final answer. It's just something that I need. And then when I come over here, I'm going to find g of -1. And so that's going to give me the absolute value of -1. Well, what is the absolute value of -1? Isn't it just 1? Yeah.
Mhm.
And so now I have f of -1 and I have g of -1. So that's good. And so what I can do next is I can go back and I can add those values together. Now, typically I would have you write all of this out, but I get real tired of writing all this stuff out. I don't need to write this middle out every single time. Do I know what f of -1 is? Yeah. Do I know what g of -1 is? Yeah. And so I'm going to have 13 plus plus +1. What is 13 plus 1?
14.
14. And so when I take f and g and I add them up and I plug the value of x of a -1 in there, my final answer is 14. Done with letter A. Now, when we do the rest, I'm going to omit this middle part because I want to show you how to do that. And so if we look at letter B, it's the same idea, except for obviously now I'm subtracting. And so I say, okay, well, what is f of -1? Well, that's the number 13. Here's my subtraction sign. What is g of -1? Well, that's the number 1. What's 13 minus 1?
12.
Done. And so then if I look at the next problem, I'm going to be multiplying. And so I say, okay, well, what is f of -1? Well, it's the number 13. And here's my multiplication dot. And I say, okay, well, what is g of 1? Well, it's the number 1. What is 13 times 1? 13. Done. And then, of course, if I look at letter D, I need to divide. And so I would say, okay, well, what is my f of -1? Well, it's the number 13 on top. And what is my g of -1? Well, it's the number 1 on bottom. And when I simplify this fraction, 13 divided by 1, just 13. Done. All right, so this is the second type of problem that we might see where you have to actually plug in some values rather than just looking for the numbers given. So what are your thoughts about this particular example number 2? Take a minute, look at it. I'm going to take a drink of water.
So once we find the f of x and the g of x, we can ignore the x plus 14 and the absolute value of x.
Yep, because all you
Okay.
need really are these little guys right here. These are the numbers that you need. And if you look, 13 and 1, 13 and 1, 13 and 1, 13 and 1. We didn't even look at this once we actually got it. So yes, Sarah, what you're saying is right. All right, any other questions, any other problems right here, right now, before we move on? Because this is the a second type of example that you're going to see with this. So we've done it with just values, which was the easiest. Now we've done it with functions. Now we're going to, now we've done it with functions and values. Now we're just going to do it with functions, okay? We ready for that?
Yeah.
Okay, and this will be the third and final type of problem that you're going to see when it comes to adding, subtracting, multiplying, and dividing. So let's get through this, and then you think really hard and ask me the questions that you're going to have, okay? So, example 3. F of x equals x squared plus 1, and g of x equals 4x. And so what I'm going to have to do here, letter A, is find f plus g of x, and then find its domain. So things have already changed. Letter B, I need to find f minus g of x, and then find its domain. Letter C, f times g of x, and then its domain. And I'm going to have to squeeze, I guess, letter D over here, because we got to do it. F divided by g of x, and then its domain. Okay, so a couple of things have already changed. The first thing that probably sticks out to you is that I'm asking you to find the domain. Well, we haven't done that yet today, okay? The second thing that you're probably going to notice is instead of having a number right here, on every single one of these, I still have just an x. Okay, do we see those two different things happening? On every single one of these, I'm asking you for the domain. I haven't done that yet. And then on every single one of these, instead of having a number, it's just the value x. We see that? Because here's what's going to have to happen. When we do this, the first thing that I want to do is I want to look back up. If you look at the notes where we wrote, it was the last sentence that we wrote before we started example 1. We said that the domain of our new function was going to be the intersection of the domain of f and the domain of g. But we have to also keep in mind, while that's happening, that regardless of when I'm dividing, my g cannot be a 0. And so we're going to take a look at these functions. We're going to say, okay, look, if you were to look at just this guy, just f, what's the domain of the function f? So my question is, question number 1, do you see a fraction with an x on the bottom? No.
No.
It's question number 2. Do I see a square root?
No.
No. And so what does that mean? It means that the domain, oh gosh, oh no. I've clicked the wrong button. I'm on the wrong page. So sorry. So that means that the domain of the function f is all reals. We agree to that?
Okay.
Okay. And so then we're going to look over at g. Okay. And we're going to say, well, do I see a fraction with this guy with a variable on the bottom? No. And then we're going to say, okay, well, do I see a square root at all? And I'm going to say no. And so since both of those are no, what's the domain of my function, which is in this case is just 4x?
All real.
Yeah. Okay. And so now when we're thinking about the domain of my new functions, since the domain of f and also the domain of g are the same, right? We see that. So what that means is, for the most part, the domain of all of these guys is probably going to be all real, except for this one, because we can't have g equal to 0. So just keep that in mind. All right, now we're actually ready to do our addition, subtraction, multiplication, division. And so this says f plus g of x. What this means is, since I don't have a value to plug in, it means I'm literally going to pick up function f, and I'm literally going to add it to function g. And so this is going to give me x squared plus 1, because that's f. Here's my plus sign, and then g is just 4x. Now we know from way back, we always want to write our answer in degree descending order. And so we're going to say, all right, well, this simplifies to x squared plus 4x plus 1. And that's it. That's all I can do. There's no other terms to combine. There's nothing I can do. That's just it. I'm done. So I've taken the function f, I've taken the function g, and I've added them up. And I've simplified the absolute best that I could, and this is what I get. What do you think about that step?
So with this step, the function is the answer.
Yes. So
It
for
doesn't have
letter
to be
A,
like a solution.
it cannot be, correct, because there's no value. It's just the x. So for letter A, what I have circled in blue right there, that's my final answer for letter A. Now, in addition to finding the actual function, remember, we want to find its domain. Well, according to our stuff up here, the domain of f is all reals, and the domain of g is all reals. And so we look in our little answer and we say, okay, do we see any fractions? No. Do we see any square roots? No. So what does that mean about the domain of this new guy? He's going to also be all reals. So A is completely and totally done. So soak that in, think about it, ask me your questions. Otherwise, we're going to move on to B.
What would it be if it was a square root or a fraction?
As far as the domain goes,
Yeah.
okay, so you're going to see the answer to that over here when we do the division as far as the fraction goes, because we're going to have something on top and something on bottom. But let's say we had a square root in here. I don't know. We would just say, oh, guess what? This has to be greater than or equal to 0. We do our solving, and then it would look something like this. You'd have your negative, you would have some number. I don't know what it would be. Let's just say to infinity. And remember how we had domains the other day? We either had a big union symbol or we had one teeny tiny little guy.
Yeah.
It's going to be the same. Okay, the way that we do those domains is going to be exactly the same. It's just going to depend on what we circle as our answer. Okay, and typically, I'm winking at you right now, wink wink, you're not going to see a square root in this type of a problem, but you are going to see the fraction, and that's going to come in just about 5 minutes. Okay, or however long it takes us to get over there. Okay, so any other questions on A before we move on to letter B? All right, so if you look at letter B, we're going to do the same thing, except now we're subtracting. And so what I'm going to do is I'm going to start with my f of x, so x squared plus 1, and then my subtraction sign, and then this guy's just 4x. Well, okay. And now there it is, right? Here's my f, here's my g, there's my subtraction sign. My goal now is to simplify as much as possible. And again, since I don't have any like terms here, I always want to write this thing in degree descending order. So I'm going to have x squared minus 4x plus 1. And that's it. There's nothing else I can do here. So bam, done. And so then, of course, I need to find the domain. Well, I have to remember that my domain of x is all reals. My domain of g is all reals. There's no fractions in this guy. There's no square roots in this guy. So what's this green guy's domain?
All real.
It's also all reals, yeah. And now B is completely and totally done. So look at B. What do you think? Any questions, any problems with this? Okay. So then guess what? We're going to do letter C pretty much the same way, except for here. Let's see. Let's get a different color we haven't used. We're multiplying. And so we're going to take our f of x, which is x squared plus 1, and we're going to multiply it by my g of x, which is 4x. And we know that when we have these little binomials and these monomials, we have to do our foiling, so to speak. So I'm going to say, okay, well, what is x squared times 4x? Well, that's going to give me 4x squared. And what is 1 times 4x? Well, that's going to give me 4x.
Wouldn't it be 4x cubed?
Oh, yes. Oh, no. Thank you. Let me back it up here. Thank you, thank you, thank you. 4x cubed, okay? And then when I do 1 times 4x, I'm going to get plus 4x. And if I could, I want to combine my terms. I want to write them in degree descending order. Just so happens I can't combine anything. They're already in degree descending order. And so here's my answer. And then I say, okay, well, I need to find the domain. And I know that the domain of f is all reals and that the domain of g is all reals. And so I look at this orange example and I say, okay, do I see any fractions? No. Do I see any square roots? Also no. And so the domain of this guy, all reals. C is completely and totally done. So take a sec, look at it, see what you think, and then we'll do this last one.
Wait, so why is C all reals?
Okay, so we all agreed at the beginning that the domain of letter F was all reals because there was no
Yeah.
fractions and there was no square roots. We also agreed that G was all reals because there's no fractions and there's no square roots. And so we did our function addition or subtraction or multiplication or whatever, and this is what we got. And we said, okay, well, coming in, his parent functions, we can call them, both of their domains were all reals. So this guy is likely to be all reals, but we got to check. And so we say, okay, question 1, do I see a fraction with a variable on the bottom? No. And then question 2 is, do I see a square root symbol? And the answer to that is no. And since both of those answers are no, there's no restrictions here. And so because there are no restrictions, that tells me that the domain is all reals.
Oh, okay.
Okay. All right, so last one. This is where we have to divide, okay? And so what's going to happen is we're going to take our f of x, which is x squared plus 1, and we're going to divide it by our g of x, which is 4x. And like always, when we have a fraction, we always want to try to simplify if we can. Well, we've learned that we do not do this. We cannot just go do, right? It's either all or nothing. And we say, hey, guess what? This is a thing and this is a thing. And these two things are not the same. And so because these things are not the same, there's literally nothing else I can do. So this is my answer as far as my function goes. That's my new function, right? That's what should be going right here. And so now what I have to do is I have to find its domain. Well, we all already agreed that coming in, the mom and dad's domain, so to speak, was all reals. So it's likely this guy could also be all reals. However, we have to check. And so question number 1, do we see a fraction with an x in the bottom? Yes, we do. And so we know from way back a couple of days ago that when we have a fraction and it has an x in the bottom, we know that the bottom only cannot equal 0. And so if I were to divide both sides by 4, I would get that x cannot equal 0. And so if I were to draw my number line, that means all the numbers in the world, so all these guys, all of this, but not 0. And then all of these, okay? And so I'm so running out of space. I'm going to put him, let's see, up here where this red line is, because I don't really need this red line anymore. I'll get it in purple so you can see it. So I'm going to say that all the numbers except for 0 are good. And so that means all of these numbers, not you, and all of these numbers. So my domain is going to be negative infinity to 0, union 0 to infinity. And this purple domain should really be down here with this guy, okay? But we've just run out of space. Okay, so we are completely and totally done with this example. So we added them, we subtracted them, we multiplied them, and we divided them. And the only issue with our domain is when we divided. I'm winking at you right now. That's usually going to be the case. Okay, really the only time the domain is going to differ is typically when you divide. So take a sec, look over this page, think about what we did. Let me know what kind of questions you have, because if not, we're going to move on to the second topic in this section. So take a sec, think about it, let me know.
So with D, will the domain normally always be 0 because it just can't equal 0, or will there be instances where you can divide it out and actually get a different number?
Are you talking about right, hold on. You talking about right here?
Yeah, how it says
Yeah.
you can't equal 0, so the 0 is what is excluded. So that's
Yes.
what your domain. Will it ever be anything other than 0? Or no?
Sure. So what if, let me erase just a little bit of this and let me just show you what that is so that you can see. So let me get rid of this. So what if when we did our division, let's say we had, and I'm making this up totally. So let's say we had, I don't know, 2x over x plus 1, let's just say. Well, we know that the bottom cannot equal 0. So that would mean in this case that x cannot equal a negative 1. And so if you were doing that, then what would happen is instead of having a 0 right here, I would have a negative 1 because I would be excluding the number negative 1. So yeah, it's always going to start out cannot equal 0, but it's not always going to be that x can't actually be that number. It's going to be whatever number would make the bottom be a 0. It can be a whole number. It can be a fraction. It can be a positive. It can be negative. It could actually be a 0 like it was down here, but not all the time. Okay?
Okay.
Okay. All right. Now, I think that we're ready to move on to the next topic. We can always circle back if we need to, but let's take a look at the next thing that this section talks to us about. And here's another word maybe that you're not sure. Okay, so let me write it all out and let me explain it to you. So the next topic is what we call function composition. Okay, now function composition, if I had to guess, I would say it's brand new to 99% of you. Okay, so before I even tell you what we're doing, I'm going to break it down into words that make way more sense for you. Okay, and we're going to say this. We're going to say basically, we are taking one function. We are taking one function and we are putting it inside, and I'm going to put inside in quotes, and you'll see what that means in a second, inside another function. And you're going to think that's super odd, okay, but let me show you, okay? So before we talk about the technical terms, basically here's what we're doing. We're just going to take one function and we're going to put it inside another. That's like the easy way to put it, okay? But now we have to get technical, of course, because there's words and phrases and symbols that we need to know, but this is what we're going to do. Ooh, someone has done this before. Okay, fantastic. Okay, so here we go. We're going to say, let f of x and g of x be two functions. Okay. We're going to say that the composition of f and g, which is going to look like this. So written as, and just write all of this down, and then we'll come back and we'll talk about it all. Okay. All right, now I know this looks weird. Okay, believe me, but when I first saw this, I was like, what? But this right here that I have in purple, this is what we're talking about. This is super duper important. Okay, so let me give you a second to write all this down, and then we'll talk about it in actual words, and then we'll do it. Okay. So we already said that basically we're taking one function and we're putting it inside another. And so then we start our technical stuff, and we say, okay, let f of x and g of x be two functions. The composition, which just means pick up and put inside, of f and g written as this, which this fog like the word fog, right? F-O-G?
Yeah.
Okay. How many of you like driving in fog?
Not at all.
I don't either. Okay, so we don't like fog in real life, and guess what? We're not going to like fog in math. And so what's going to happen is, it says right here, when we have this F-O-G, this is actually not the letter O. It's just this open circle. It's just a little symbol. And that's the composition symbol. Just like if I were to have, like F times G, we would know that this is the multiplication symbol. When I have that open circle, I know. Okay, so someone's done it before but wasn't quite sure. Okay, so we know that when we see that open circle, that tells me composition. Well, here's what I like to do, and I like for you guys to do this as well, even if you think you have a pretty good grip on it. I like to say, well, I don't really like driving in the fog. Okay, I hate it. It's hard. I like to get to where I can see. So here's what we're going to do. When we see composition, which, by the way, I should probably tell you this, this is read as f of g of x. I know that sounds dumb, but that's how you say that. F of g of x, okay? We're going to rewrite it to this. Do you agree that this is g of x? That if I were to write that, that's how I would say g of x. Okay.
Mhm.
Yeah. So what if I went ahead and I stuck another f out there? Wouldn't you say that this is f, this is of, this is g, this is of, and this is x? F of g of x. We got to understand that first. And if you take a look at this, what you can see is, hey, look, here's the function g of x. Where is it? Well, it's right inside f. Basically, we're taking one function and we're putting it inside another. That's it. Okay, now if you have, I don't know if you have or if you haven't, but if you have kind of been looking around in Blackboard, you're going to see at the end of today's lesson, there is several pictures, and it says fun pics to help you visualize. Okay, and so what's going to happen is basically we're picking something up and we're sticking it inside something else, and that's it. Now, there's 2 other sentences I need to write before we look at a problem, but I've run out of space on this page. So let me go to a new page. Let me write those sentences, and then I promise once we look at an example, all of these words will make sense, okay? Because right now this is just a bunch of gibberish. So the other things that we need to know, that should just be black, I guess. We're going to say that the order of the F and the G absolutely matter. Okay, and I'm going to show you. They matter, so we have to be careful. The order matters. So if we say F of G of X, what we are doing is we are putting X into G. And you can see that X is going into G. Then we are putting that value, whatever it is, into F. So we're going to take our value of X and we're going to put it into G. And then that's going to give us a new value. Whatever that number is, we're going to put it into F. So we're taking something and we're putting it in. We're taking something and we're putting it in. That's it. But if the problem states G of F of X, well, then we would put X into F, then put that value into G. And so what would happen is we would say, hey, look, let's take this X and let's put it into F. That'll give me some type of a value, whatever. And then I would take that value and I would put it into G. And so the whole idea behind this is that the order of the F and the G are going to make a difference. And so if you have a question that looks like number 1, and it says F and then G and then X, that is read F of G of X. F of G of X. If you have a question that looks like number 2, that is read G of F of X. So take a sec. Okay, I know it's just kind of weird. Take a sec, look at this, think about the words, okay, think about what they mean. And then when everyone, feels like we're ready, we will actually do a problem and we will find these values and you will see what I mean by all of this putting in stuff, okay? So before we move on, and before we look at an actual example, anybody have any burning questions before we try? Okay, so then let's try it, okay? So let me get a brand new page here. And we will start with this. We will say, so I think this was example 4. I don't remember. Okay, we're going to have f of x equals x to the 3rd plus 3. Okay, and g of x is going to equal x to the 3rd plus x. And we're going to have 2 parts to this question. And part A is going to say, hey, I need you to find, find okay, so here's the problem. X to the 3rd plus 3, that's my f of x, and my g of x is x to the 3rd plus x. And letter A says, hey, I need you to find, how do you read this? I want someone to read this to me. How do I say that?
Find f of g of -2.
That's perfect. Now, here's the thing. Do you guys like driving in fog? No. Okay, so before I do anything, I always advise this. I always say, let's rewrite this so that I can see where I'm putting things in. So someone already said f of g of -2. So my advice to you is get rid of the fog every time because I can't see anything in the fog. Now, once I have the fog gone, I can take a look at this and I can say, oh, well, I'm going to take this -2 and I'm going to put it into G because I always start on the inside and work my way out. And that's going to give me some value. I don't know what, but once I get it, I'm going to take that whole value and I'm going to put it into F. So why don't we try that and see what happens? So having said that, here's what I'm going to do. I'm going to take the number -2 and I'm going to put it into G. So I'm going to have G of -2 like that. And that's going to be, well, -2 to the third plus -2. And now I'm just calculating this. That's all. And so when I take -2 and I raise it to the third, well, that's -2 times -2 times -2, which is going to give me a -8 and then a plus -2. Well, -8 plus -2 is a -10. Everybody on the same page of that so far? And so I get to say that G of -2 is -10. Now, if I go back up to where my problem is written, where it's asking me to find, watch what can happen. I can get rid of this G of -2 business. And what's the number that I just found? Well, -10. And so now what I'm doing is I'm taking the value, which is -10, and I'm putting it into F, which is over here. And so I'm going to say, okay, well, F of -10. And that's going to be -10 to the third plus 3. And now I'm just calculating this. And so I'm going to have, well, -10 times -10 times -10, which is going to give you the number -1000. And then I'm going to add 3 to that, and I'm going to get -997. And so up here, at the very beginning, where I made a mess of things, here's what I'm going to say is my total and final and complete answer. I'm going to say that F of G of -2 equals -997. And this that I'm about to circle, if I can ever get my pen to work, here we go. This right here is my total and complete and final answer. So take a look, see what you think about the steps that we did. We took -2, we put it into G first. That was right here. We did our calculations, we got this number. Then we took that value and we put it into F right here. And we did our calculations and we got this number. And so we can say, after we've calculated this, that our total and complete and final answer is what I have circled. What do you think? Questions, problems, issues? Okay. Well, there's letter A. Now, according to the notes that we just did, we said that the order of the F and the G matter. Okay. And so what's going to happen, I'm going to ask you to do, or I'm going to ask us to do letter B. And in letter B, we're going to find, instead of finding F of G of -2, we're going to find G of F. So I'm going to show you, we're going to do the same type of thing, okay, but the order will matter. And I'm going to leave this answer up just so we can see it. But then we're going to compare and say, oh, hey, look, it does matter. So letter B, I'm going to ask you to find G of F of this -2. But again, even though this looks like golf, it's still fog, so to speak. It's still the F and the O and the G. Remember, I don't like fog. And so I'm going to rewrite this. And it's going to be G of F of -2. And so what's going to happen is I'm going to take -2 and I'm put it into F first. And so I will have F of -2. And that's going to be -2 to the third plus 3. Well, when I do this calculation, -2 to the third is -8, plus 3 is a -5. Okay, and so then what has happened is this, goodness, this F of -2 has turned into the number -5. And so now I need to find -5, G of -5. So G of -5, I'm going to take -5 and put it right here. I'm going to have -5 to the third plus -5. Well, when I do my calculations, -5 to the third is -125, and I add a -5 to that, I get -130. And so my final answer for this second part, so this was part A, this is part B, we're going to say that G of F of -2 equals -130. And so now take a look at how we got letter B. What do you think? But now we're done. We found F of G of -2. We got a number, and then we found G of F of -2, and we got a different number. And so this is just to prove to you that we do them the same way, ideally, but that our answers are different, and because the order is different, and the order matters. And so what do you think? We've done a composition problem.
Seems pretty simple.
Okay. Not bad. Okay. So what I would like to do next is, again, when we're given numbers, it's pretty straightforward. Okay. We didn't have this wasn't super difficult. It took us a second, but it wasn't the worst thing we've ever done. Okay. And so what I would like to do is I would like to take a look at another type of a problem similar to this. And instead of them giving us a value right here, it's just going to stay X. And so just like when we added, subtracted, multiplied, and divided, yeah, we're going to take these functions as a whole and actually put them into one another versus actual value. So let's take a look at this next one. Okay, we're going to have f of x equals x squared minus 4. And g of x equals x squared. And so what we're going to do, two parts to this one is, so A, I want you to find f of g of x. And the reason why I'm making it so apparent that I'm writing this fog out every time is because Hawks is going to write it to you in fog notation. And I want you to be able to rewrite it. So I want you to find letter A, find f of g of x and its domain. And then letter B, we're going to flip this thing around and find g of f of x and that guy's domain. And so before we do anything, we want to look back at the two functions that we're given, and we want to find the domain of each of these little guys individually. So if we look at f of x, just this guy, do we have any fractions? No. Do we have any square roots? No. And so the domain of this guy, all reals. And so then I look over and I look at g and I say, okay, just looking at this, do I have any fractions? No. Do I have any square roots? No. And so the domain of g is also all reals. So it's very likely that the domain of the functions that we're about to get are probably going to be all reals. Okay, so let's see. So here we go. On letter A, I want to rewrite this, getting rid of the fog, which tells me f of g of x. And so what's going to have to happen, since this x value is not an actual number, I can't put x into g, okay, because there is no x to put in. So what's actually going to have to happen is I'm going to have to pick up this entire function g of x and put it into f. So I'm going to take this, which is g of x, and I'm going to scooch myself over here to f, and I'm going to put it right here. Okay, this is just like the old plug and chug. And so I'm going to write that f of g of x equals, in parentheses goes my x squared, right, because that's this guy, and I'm only replacing the x. And so this guy, this little square is still there, and then a minus 4. Now, bear with me for one moment. What if, let's say here's my finger. Okay, here's my finger, and I'm covering this up, let's just say. Would you agree that if I put my finger there and I covered up that x squared and I could rewrite an x over top of it, wouldn't you not agree that this right here is what I actually started with? You agree to that?
Yeah.
Yeah. And so what I'm doing is I'm taking what I'm starting with and I'm just replacing the x only with this function. And so here it is. And so what I have written is x squared squared minus 4. And you told me that if I were to cover this up, it's what I started with and all is good. So that's great. And so now what I have to do is I have to go ahead and simplify this. Well, if I have x squared and I square it, that gives me x to the 4th. And then this minus 4 is just hanging out. And I say, okay, well, x to the 4th minus 4. Can I simplify that in any way?
No.
No. And so for this particular problem, part A, this is the answer. So I would say that f of g of x equals x to the 4th minus 4. And so I say, okay, well, there's that. But I also need to know its domain. And so I look at my answer, okay, and I know coming in that it's likely to be all reals, but I have to check. And so I say, okay, and this guy here, any fractions? No. Any square roots? No. And because of that, all reals. Now take a sec, take that in. What do you think? I took the function g of x and I popped it into f, and then I simplified as much as I could. So think about that. Let me know, okay, because what we're about to do is kind of the same thing, but we're going to be doing it the other way. All right, so now down here, I need to find g of f of x. Well, again, I don't like the way that this looks, so I rewrite this as g of f of x, like that. And so again, I start in the middle, which is x. Well, I can't put x into f because there's no x. And so what I'm actually going to have to do is I'm going to have to take the whole function f of x and put it into g. So that means I'm going to take this, which is all of f of x, and I'm going to put it right here. And so I'm going to rewrite this as x squared minus 4, whole thing squared. Now, do you agree that if this, again, now my finger got a little fatter. Here's my finger, let's say. if I covered that up with my finger and I just had an x here, do you agree that this x squared is the same thing as x squared up here in G? Okay, so what I've done is I have just taken my f of x and I plopped it into where G was. And so now I have this brand new function.
So will our sign switch? I'm sorry, I'm ahead of it, but
Say it again. I didn't hear you. Does what switch?
will our sign switch after we do it
Which signs?
with a -4?
Okay, so maybe. I'm not sure if I 100% understand what you're asking me, but we have to get rid of this square somehow. So let's so hold on just a sec, okay?
Okay.
Probably this will answer you. So again, once we get this value, we say, hey, we can't just leave it like that. We need to simplify. And so when we have a binomial which has two pieces like that, and it's being squared, what's our favorite F word that gets rid of that square? Anybody remember? FOIL. So I'm going to have x. Oh, hold on. Oh my gosh, Amanda. X squared minus 4 times x squared minus 4. And I'm going to have to actually FOIL this thing. And so when I do that, x squared times x squared, it's going to give me x to the 4th. And then x squared times 4, negative 4x squared. And then x squared times x squared plus x to the 4th. No, wait, hold on. I did that already. I got to back up because I'm getting too messy and I can't see what I'm doing. Okay, negative 4 times x squared, negative 4x squared, and then negative 4 times negative 4 is positive 16. And so this is a real mess, so let me fix it up a wee bit. We know what we're looking for, so I'll get rid of this. And so then once I get this written out, once I FOIL all this out and I have simplified it, I'm going to be left with x to the 4th minus 8x squared plus 16. And so that's going to be my g of f of x. And so then I say, okay, well, coming into this, I knew that each of the functions that I started with, I knew that their domain was all reals. And so it's very likely that this guy will also be all reals. And so then I'm going to look at this and I'm going to say, well, I got to check. So question 1, any fractions? No. Question 2, any square roots? No. And so the domain of this guy is all reals. And so if you look in the red and in the black, this, or I'll put it in yellow so we can see a little bit better. This is the difference. This shows us the difference of how the F and the G matter. And so when you're doing a problem like this, it's super imperative that you pay attention. Are you putting the F into the G, or are you putting the G into the F? Now, what are your thoughts on this particular problem? This is the first one where we actually used functions and we just put values in. Any questions, any problems on this? We can't overthink this because it's literally just, hey, pick this up and put this in. In fact, I want to show you something real quick. It'll just take me a second, but it's worth the time to look at. It is. So if you look, let's see. If you take a look in our Unit 4 folder and you look at today's stuff, which is Unit 4.5, and you scroll all the way down to the bottom, here's some pictures, okay? And it says, here's some fun pics to help you try to visualize the f of g of x and the g of f of x, okay? And I like these ones because who doesn't relate to food, right? And so if you take a look at this last one, this is an omelet. And so if f of x is the bread and g of x is the egg, okay? And so if we're taking g of x and we're putting it into f, we're going to have a sandwich and the egg is in the middle. But if we're doing the opposite and we're taking f of x and we're putting it into g, our sandwich is going to have eggs on top and then bread and then eggs on the bottom. That's literally the difference. If you look at this one with pizza, if f of x is the pizza and g of x is pineapple, if we take g of x, which is pineapple, and we put it in f of x, we have pineapple on a pizza. But if we do it the opposite way, and we take f of x, which is pizza, and we put it onto g of x, we're going to have teeny tiny little pieces of pizza on a piece of pineapple. And then my personal favorite, because my gosh, burgers and pizza, come on, is if f is a pizza and g is a burger, and you take g of f, or if you take g and you put it into f, you're going to have a hamburger that's made out of pizza. But if you take f and you put it into g, you're going to have a pizza that is made out of a hamburger. And so I like these pictures because I think they're a little funny. And I think that, you know, again, we relate to food sometimes easier than just words. So look at those if we need to. But back to our example. What do you think? Questions, problems with this?
Seems simple.
Okay. All right, so then let's take a look at the last topic. Okay, there's one more topic and then we'll be done. And so the last thing that we're going to do in this section is called decomposing functions, which sounds scary, okay, but it's not. So let me write some things and then we'll do it. This is, oh my goodness. I haven't written in like 3 days and my handwriting is a mess. Decomposing functions. Okay, so just a minute ago, the second topic was function composition. And basically what we did was we put them into each other and we made a new function. Well, now we have decomposing functions, which is basically the opposite. Okay, so here's what we're going to say. We're going to say to decompose a function. Okay, now I'm putting this into my own words. You're not going to find this written in a textbook. These are my words. We are turning one huge function into one big and one small function. Okay. Comma, so that, and I promise this will make more sense in a moment, so that if I put the small function into the big function, I would get the huge function. I would get, now I know this is kind of wonky, okay, I promise once you see it, you'll be like, oh, okay. So take a minute, make sure you have that written down. So to decompose a function, we are going to be given one huge function, okay? And our goal is to take that huge function and to split it into one big and one small, okay? So that if I were to take the small function and put it into the big function, I would actually get the huge function that I started with. Okay, so let me make sure you have that written down. All right, I've been really thirsty today, so sorry for that slurping. And then we'll do it. And I have several examples so that you can get a good visual of this. And so before we look, and then these, I have 4 examples. We may not need them all, but then I'll be done. So if you are one of the folks who wanted to stay and chat with me, please do. But if not, then this is going to be the last couple of examples. And then, you'll have Hawks for this section, and we'll meet again tomorrow. All right, so here we go. Let's take a look at what I'm saying so that you can visualize this in your head instead of just a bunch of words. So we're going to say, I'm going to give you this huge function, and it's going to be f of x equals the cube root of 5x squared minus 1, and on the outside, a minus 2. Okay? And so what I'm trying to do is I am trying to find g of x and h of x, which just means 2 other functions, such that the f of x that I'm given is equal to g of h of x. Now, I know there's a lot of writing right here, okay? And you're like, oh my God, what? All right, but here, watch what I'm gonna do. I'm gonna put a big letter B over g of x, and I'm gonna put a big letter S over h of x. Actually, I'm gonna write the word big and small. So what I'm trying to do is I'm trying to find 2 functions, one big, one small, so to speak, so that if I were to take the functions that I'm about to write down and put h back into g, I would get what I started with. And you're thinking, oh my gosh. So here's what I want you to do. I want you to look at the function that we're given, which is this guy. Okay? Now, if pretend that's all you can see. Look at that thing and say, okay, what's the biggest thing I see happening right here? What's the biggest type of math that I see going on in this function? Anybody want to give that a shot?
The square root or the
Okay.
cube root.
The cube root, exactly. And so the biggest thing that I see happening is this cube root. Well, in addition to this cube root happening, because you're right, that's a pretty big thing. There's some stuff for the time being, and I don't really care about this because, it's being cube rooted, so to speak. But in addition to the cube root, what else is happening to the big time?
Subtracting 2 from it.
Yeah. So watch what's going to happen. I'm going to say that my g of x is the cube root of x minus 2. That's my big function. That's the biggest thing that's happening. And so now I've taken care of this, right? It's like I don't see this anymore. And I say, okay, well, what is actually being cube rooted in minus 2? Well, it's this stuff right here. This is the tiny function. This is the small function. So we'll say that h of x is 5x squared minus 1. And so believe it or not, we're actually done, okay? This is my final answer. And so what I've done is I've said, okay, well, I've taken this function that I started with and I pulled it apart in a way such that if I were to take this function that I just got and plug it in, this little small function, and plug it in right here. So do you agree that if I took this value and I put it where this x is, that it would give me what I started with?
Yeah.
Okay, done. That's it. I mean, that's it. The decomposing functions, piece of cake. So let me get rid of some of all these markings and let you see the whole thing. All right, so what do you think, guys? We look at this and we say, okay, what's the biggest thing that's happening? And I write that down as my g of x. And then I say, okay, well, that big thing that's happening, what is it happening to? And in this case, it's happening to the stuff under the radical, which happens to be 5x minus 1. Yeah, easy. All right, any questions on this one? I have a couple more that I want to show you. And then I might have you do one without me, and then we'll call it a day. Any questions? All right, I'm moving on to a new one then. All right, so same idea. We're going to get on the second one that f of x equals, let's do 1 over 3x plus 2. And again, I need to find a g of x and I need to find an h of x. And remember, the g of x is the big thing and the h of x is the small thing. And so when I look at this, what is the biggest mathematical operation that you see happening?
The fraction, the division of it.
Exactly. And so we're going to say, okay, well, the one's on top and the stuff is on bottom. Well, what is the stuff that's being divided?
The 3x plus 2.
Done. See how easy that is? Barely any work is needed. It's just a matter of looking at the problem and saying, oh, this is the biggest part and this is the smallest part. Done. What do you guys think about that one? I mean, that took us, what, 27 seconds maybe?
And that's how easy it'll be in Hawks, just to like plug it in.
These questions are exactly from Hawks. I went through this morning and did the homework and I wrote them down. So this is a question right out of Hawks, I promise you.
Okay, sometimes Hawks gets scary.
Yeah, I know. That's why I make those YouTube videos for you guys, so that when you get scared, you can just go look at that and try to figure it out. All right, so here's what I'm going to do. All right, I'm going to split the screen. I want you guys to do these ones without me, just to make sure. Okay, because it's easy and I got to make sure you believe it. So here's 2 more questions. We're going to have 3 times the square root of x squared plus 4. Now on the outside, I'm going to have a minus 7. I need you to find your g of x, which we will call the big one, and I need you to find your h of x, which will be the little one. And then number 2 is, f of x equals negative 2 over x minus 6. And I want you to find the g of x, and I want you to find the h of x. And I'll give you about a minute to do this, because honestly, it shouldn't take you that long. And then we'll check it. All right, number 1. All right, looking at this, number 1, what is the biggest type of math you see going on in there?
3 times the square root of x minus 7.
That is perfect. So 3 times the square root of x and then a minus 7. Okay, excellent. Now, what's the small piece that's being done to?
Wait, why isn't it x squared?
Okay, because you can't have, hold on, let me see. Let me get a different color here. This little stuff right here, whatever it looks like, is what's underneath this radical. This little x squared could have very well not have been there, and it might have just been an x. Doesn't matter what it looks like. Okay, it just matters that it's under the square root symbol. Now, as far as the h of x goes, the thing that's being square rooted, that's where the x squared plus 4 is going to come in. Now, do you agree that if I were to take this x squared plus 4 written in pink and put it right here, that I would get what I started with? Yeah.
Mm-hmm.
All right, so what are any other questions right now on part 1? All right, so look at part 2, same idea. And so what is the biggest math question or math problem that you see happening there?
The division of negative 2 over x.
Perfect, so the division. So let me get my black here. We'll have a negative 2 over x. And then what is being divided, so to speak?
X minus 6.
And then so do we agree that if we pick up x minus 6 and we put it right here, we would have what we started with?
Mhm.
Okay, that's it. I'm done. Those are the notes for decomposition. Decomposition is a piece of cake. Just, it might take you a couple of extra problems, but as far as the process goes, it's very much the same thing. All right, so for this section 4.5, as far as the notes go, that's it. I'm done. So we're adding, subtracting, multiplying, dividing functions. We are composing functions by picking one up and putting it inside the other. And then we are decomposing functions by taking them apart. Those are my 3 main topics. Now, before anybody else leaves, what are your questions on these 3 main topics? Anything I need to go back and take a peek at, or have another example, or anything at all? Now's your chance, because if not, you're excused. And if
Can we-
anybody wants to stay and talk to me, I want you to do that. Otherwise, you're good to go. So anybody?
Can we do an example of the second kind of problem we did?
Okay, so let me get my notes out here. The second type of a problem, which was the putting the one in, like putting f inside a G or something like that.
Yeah, and finding the domain.
Sure, absolutely. Okay, so let's have f of x to equal x minus 3. And let's have g of x to equal 2x plus 5. Okay? And so step 1, I need to find f of g of x and then find its domain. And step 2 is me finding g of f of x and finding its domain. Okay, so the first thing that I want to do any and all times is rewrite this, getting rid of the fog, remember? So this is going to be f of g of x. And so what that means is I'm going to take g of x and I'm going to put it into f. So I'm going to take this and I'm going to put it right here, okay? Actually, I'm going to put it right here. This x is going to be gone. So what's going to happen is I'm going to have 2x plus 5. That's my x value, so to speak, and then minus 3. Okay, well, can I combine any like terms here?
No.
Yeah.
Yeah,
Yeah,
you're 5 and you're
right.
3.
Yeah, exactly. So I'm going to get 2x plus 2. And guess what? This is going to be my answer, okay? Now, when I find its domain, I've blew through this like a maniac, and we didn't find the domain of f, and we didn't find the domain of g to start with. So let's back up for just a second, okay? If I look, oh gracious, if I look at the x, f of x, I have x minus 3. What's the domain of this guy?
All reals.
All reals, exactly. And then over here, what's the domain of g?
All reals.
And so it's highly likely that the domain of A and B will also be all reals, but again, we have to check. And so when I look down here at this problem, I ask myself, okay, do I see any fractions?
No.
Do I see any square roots?
No.
No. And so the domain of A is all reals, done. So these 2 pieces, domain and this guy, is my final answer. What do you think about that?
Good.
Okay, so we're flipping it, so to speak. And down here, we'll do this in green, I suppose. We will rewrite this as g of f of x. And so I'm taking f of x and I'm putting it into g. So I'm going to take this and I'm going to put it right here. And so what that's going to give me is 2, instead of having just the x that I did have, now I have x minus 3. And then I still have this plus 5. And as always, my goal is to simplify as much as I can. So I'm going to have to distribute. So I'm going to get 2x minus 6, and then this plus 5 still hanging out there. And then I say, okay, well, can I simplify this in any way? Yeah.
Yeah.
And I'm going to get 2x minus 1.
Yeah.
And I say, okay, well, there's my answer. And then again, I know coming into this that the domain that I started with on each of these was all reals, so it's likely that this will also be all reals, but I got to check. And so I say, okay, looking at this guy, any fractions? No. Any square roots? Also no. And so because of that, bam, all reals. And then I would put, this is what you would type, and this is what you would type into Hawks. And then you're done. That's it.
Okay.
Can you make up a problem where we'll have to have like a bunch of domains figured out?
Sure. Okay, so let's see.
Like a fraction and a square root?
Ooh, no. Actually, I'm not going to do that because you're not going to have that. And there's no point, because that's slightly more confusing. So I don't want to do that. But I will give you, let's say f of x is the square root of x plus 3. I don't know. And then let's say g of x is equal to x minus 4. Okay, I'm making this up totally. And so I'm asking you to find, let's see. Let's do, I want to put g. Okay, sorry, when I have to make them up on the fly, I got to think about it for a minute. I want to find g of f of x. So this way, I'm not going to do it both ways. I'm just going to do it once. Now, before I do anything, I got to look up here and I got to find the domain of each of these teeny tiny little guys. And so if I look at g, let's do g first because it's going to be easy. What's the domain of g?
All reals.
Yeah, all reals, because there's nothing hanging and there's nothing happening over here. So all reals. Now, according to this, because I have a square root, what do I know about the square root?
it can't equal 0 and it can't, so would it be -3?
No, hold on.
Sorry.
That's okay. No, I mean, you speak, but just hold on 1 second, okay? Speak. Like now I'm talking to a dog. I'm sorry. Okay, so what I'm trying to do here is we know, generally speaking, we know that when we have something under the square root symbol, whatever that something is, in this case, it's just an x, it's going to have to be greater than or equal to 0 every time.
Okay.
So sometimes we have to do some work, sometimes we don't. But in this instance, we don't have to. So the domain for this guy is going to be 0 to infinity. Because I can't pick a -1 because I can't have the square root of a -1, right?
So with the square roots, it's the greater than, but with
Uh-huh.
the fractions, they just can't equal 0.
That is correct, yes.
Okay.
Okay, so now, here's what we're going to have to do. We're going to have to take f of x and put it into g. So we're going to take this whole entire thing and we're going to put it right here. And so that's going to give me the square root of x plus 3. And of course, that's taking care of that. And then minus 4. And then so what's going to happen is I'm going to combine these values. I'm going to have the square root of x. I'm going to have a -1. This is going to be my function. Yes?
Mm-hmm.
Okay, and so now we say, all right, I have to look at the domains. And according to my definition, whatever domains I start with, the little guy that I found, it's going to be an intersection of these two domains unless it's a fraction. Because if that's the case, I know the bottom can't be 0. So I'm going to look at this domain. I'm going to look at this domain. Well, this guy's all real, so no issues. But this guy's the one that has the restriction. And since it's 0, it has to be greater than or equal to 0. Guess what? So does this guy. So his domain is going to be from 0 to infinity. Now, I'm going to tell you right off, you're not going to see a ton of these, okay? So let's not get overly anxious about these types because you're not going to see many. If
Is it always going to be 0 to infinity?
No. So what if, let me get a purple going here. What if this would have said x minus 1, let's just say. Well, then we would know that x minus 1 has to be greater than or equal to 0. And so in this case, x would have had to been greater than or equal to 1. So this would have been a 1. And as I progressed downward, there would have still been a -1 right here and a -1 right here. And then this would have been a 1. So it's not always going to be a 0. Okay?
Yeah,
So
I think that's what I tried to get the -3 from.
I know what you tried to do because you were looking at this value. Okay, but that's not exactly the way that we do it. Okay?
Mm-hmm.
Okay, I still see several of you hanging out, which I love. So any other questions on this section before we chat about stuff from the past? Oh, I'm so sorry, you guys. Somebody blew their horn. Now the dog's barking. Okay, so give me 1 second to turn off this recording of this lecture, and then I'll start answering questions from the past. So give me just a second here, okay?
Mm-hmm.